Hello, my dear students. So today we are going to discuss about a very important rule of chemistry, a very important reaction of chemistry, that is Markonikov's rule. So what is this Markonikov's rule? Where we can apply this Markonikov's rule? We will discuss today in this video with the examples. So this Markonikov's rule, it is basically applied in case of unsymmetrical alkenes. Unsymmetrical alkenes. So what is unsymmetrical alkene? First of all, we have to understand that unsymmetrical alkene means if there is an alkene where both the carbon which are bonded by double bond do not have same substituent, they have different substituents. For example, here in one of the carbon there are two hydrogen atoms, whereas in the other carbon atom, suppose there is an alkyl group and a hydrogen. Here we can see clearly that the two carbons have different substituents. So this kind of alkene is called unsymmetrical alkene. Or we can take another example of this unsymmetrical alkene where there is CH3 in one of the carbon, but other carbon have both hydrogen atoms. Then this is called what? Unsymmetrical alkene. In place of this R, there may be any other substituent also. Or here, if the alkene have two alkyl groups like this, R1 and R2, and the other carbon have one of the hydrogen atom, and in other branch there is suppose R3. Then in this case also, this is also unsymmetrical alkene. So basically we apply this Markonikov's rule in case of unsymmetrical alkenes. Now this Markonikov's rule, it is one of the type of addition reaction. So what is addition reaction generally? So whenever we talk about the addition reaction in organic chemistry, then in addition reaction, this double bond or triple bond, if there is, then that double bond or triple bond is converted into single bond. Then this type of conversion is called what? Addition reaction. Addition reaction. So this Markonikov's rule is applied in case of addition reaction of unsymmetrical alkenes. Now, what happens in this Markonikov's rule? Let's see. Let's try to understand with some example. Here one more thing. In case of addition reaction, while adding the reagent to this unsymmetrical alkene, the reagent must be unsymmetric. If unsymmetric reagent is added to unsymmetrical alkene, then only we can apply this Markonikov's rule. So what is this unsymmetric reagent? Generally, acids or hydrogen halides. Hydrogen halides are called unsymmetric reagent because in this there are two type of atoms. One of the atom is capable to lose electron, whereas the other atom is capable to accept electron. So this kind of reagent, which is formed by the combination of two different atoms, where one atom is capable to donate electron, other atom is capable to accept electron, then such reagent is called unsymmetric reagent. So Markonikov's rule is applied in case of addition reaction of unsymmetric alkene with unsymmetric reagent. Now what happens when this unsymmetric reagent is added to the unsymmetric alkene? Whenever we talk about the addition of this unsymmetric reagent to unsymmetric alkene, then in that case what happens? This unsymmetric reagent, then this electronegative part and electropositive part breaks and form electrophile and nucleophile. Then the negative part is attached to the more substituted carbon when the bond breaks. It means it forms the new product like this. Halogen get attached to the carbon where there is more number of substituents, whereas the hydrogen part attaches to the carbon where there is more number of hydrogen. Hydrogen goes towards the carbon atom having more hydrogen, whereas the halogen or the negative radical which is formed from this unsymmetric reagent gets attached to the carbon which is substituted. So this is called what? Markonikov's rule. Now in this Markonikov's rule, here X represents what? Halogen. So there are different halogens. We know that, like whenever we talk about the halogens, X may be iodine or bromine or chlorine or fluorine, any one of these. But generally in Markonikov's rule, we take bromine. So because anti-Markonikov's rule is applicable only in case of bromine, not in other cases. If there is hydrogen bromide, then that hydrogen bromide shows the anti-Markonikov's rule also. That is why in Markonikov's rule also we take bromine. Now let's see what happens in its mechanism. If we talk about its mechanism, then first of all, this hydrogen halide, let us take hydrogen bromide. In this hydrogen bromide, there is a bond between hydrogen and bromine. This hydrogen and bromine, they have a pair of electron for the bond. Now this pair of electron shift towards the bromine. Due to that, hydrogen develops positive charge and bromine develops the negative charge as the electron move towards the bromine. So this is called electrophile or electron loving group, whereas the other one is called nucleophile, the nucleus loving group. And after that, after the formation of electrophile and nucleophile, this hydrogen which is positively charged here, or the electrophile, start searching electron because it is electrophile. So whenever it comes in contact to an unsymmetrical alkene, suppose we have unsymmetrical alkene like this, then we know that in the alkene there is a pi bond which is weak. Now this electrophile or H plus comes in search of what? Electron, and it observes that there is a weak pi bond in the double bonded hydrocarbon or the unsymmetric alkene. Now this pi bond is broken. As we know from the electromeric effect, whenever a reagent is exposed to unsaturated hydrocarbon, then what happens? This pi electron shift towards the carbon atom which is less substituted, or we know that this methyl has capacity to give electron. So this carbon leaves this electron, and due to that the electron move towards the other carbon atom, both the electrons, due to which it develops slight negative charge and it develops slight positive charge. Now, as we know, this hydrogen ion, H plus ion or electrophile, which is searching electron, here electron is available in this carbon. So this hydrogen ion, H plus ion, attacks this carbon and get connected here in this step, due to which what is formed here? Carbocation is formed. Carbocation is formed here. Now this carbocation, where the carbon has positive charge, it will attract this nucleophile which is in search of nucleus. Due to that, what will happen here? This bromine will attack to the positively charged carbon and it will form what? It will change like this. We can write like this here. After the addition of hydrogen, it will change like this, and then the bromine will attack to this carbon and it will change into this structure. This structure is known as what? 2-bromopropane. 2-bromopropane is formed. So what the Markonikov rule says here? The negative part of the reagent gets attached to the highly substituted carbon, whereas the positive part of the reagent get attached to the carbon having more number of hydrogen. This is Markonikov's rule. But sometime we may get another product also in this reaction as minor product. This 2-bromopropane is the major product of Markonikov's rule, whereas sometime instead of this. The reaction may occur like this also. This methyl group, this hydrogen, and the electron may shift towards this also, this carbon also, due to which the hydrogen may get attached here, and here it will change into carbocation after the shift of electron towards this carbon, and the hydrogen will attack to this carbon. So this carbocation, when combines with this bromine, which is negatively charged, then what will form here? It will form this structure, which is known as 1-bromopropane. 1-bromopropane. So this is the minor product, but 2-bromopropane is the major product. Major product in case of Markonikov's rule. Here, one thing I would like to make you clear, that electromeric effect also says that while breaking the pi bond, the electron will move towards that carbon which is not connected to any electron releasing group. If we see here, which one is connected to the electron releasing group here? This carbon is connected to electron releasing group. So by electromeric effect also, we can do this, and we can get this product 2-bromopropane as the major product, but sometime we also get this 1-bromopropane as minor product in this Markonikov's rule. Now, if we talk about the formation of this carbocation, you know about the stability of carbocation. Stability of carbocation. Then which carbocation is more stable? Generally, 3-degree carbocation is more stable than 2-degree. 2-degree is more stable than 1-degree. If we see here, so here this carbocation is 2-degree carbocation and this carbocation is 1-degree carbocation. So more stable carbocation is formed here, and due to that what happens? 2-bromopropane is formed as the major product, whereas 1-bromopropane is formed as the minor product. So this is about the Markonikov's rule. So we have to apply this Markonikov's rule like this. For today, only this much in this video.